4.5 is over counting principles, which you guys will remember as permutation, combinations, probability. So we're going to look at how we can answer probability questions with some of these principles, like N choose R or NPR. So we're going to look at some of that notation and review what it means, and then do some practice problems. So given the numbers 1 through 9, draw two numbers out with replacement, meaning that if I have numbers 1 through 9 in a bag, and I'm going to pull out a number and then put that number back, that would be with replacement. So what is the number of ways that you can get a sum of 8? So one of the organizational strategies I use is kind of making tables. So if I did a 1, 2, 3, 4, 5, 6, 7, 8, 9 as my possible first numbers, in order to get a sum of 8, there's only a certain number of combinations that are going to give that. If I get 1, it has to be a 7, 2, a 6, 3, a 5, so on and so forth, all the way out to 8 here. I have an N here because there's no possible pairing that can go with 8 that will create a sum of 8. Same thing here with 9. There's no negative numbers, there's no zero numbers. So I have 1, 2, 3, 4, 5, 6, 7 possible combinations that work. But then the question is, how many possible combinations are there of numbers that would give me any sum? So if there were 1 through 9 by 1 through 9, I can say 9 possible draws on the first one, 9 possible draws on the second one, which means there's 81 possible combinations and only 7 of those possible combinations. So if it were a probability, it would be 7 out of 81, or if it was just the number, then it would be 7 possible ways. What, however, if there were no replacement? How would that look any different? So let's say I've got 1 through 9. No replacement eliminates the possibility of having a 4 by 4. So then I would have 1, 7, all the way down to 7, 1, and then these two are not possible with 9 possible combinations. Here, I initially had 9 numbers to choose from, and then I only had 8 numbers to choose from because I didn't put the first one back, which means 72 total combinations are possible, 6 of those being favorable. So if that were a probability of having this occur versus just number of it occurring. Okay, the fundamental counting principle, which we know as the multiplication rule in the past, is just simply if there's a certain number of events, we're going to call it k, you could write this as n sub 1 times n sub 2 times n sub 3 times ellipses n sub k. So what are some different ways we could look at this? Let's say I'm going to build a sandwich, and there's 3 different types of bread, 4 different types of cheese, and pickles, yes or no. So maybe it's not a very exciting sandwich, but it's a probability sandwich, so don't give it too much weight. So if there's 3 different possibilities, I could build 1, 2, 3. 4 cheeses off of each one of these would be 4 off of this one, 4 off of this one, 4 off of this one. So if I were just looking at those 2 options, then I would have 3, 4, right? 2, 4, 3, 4. So I would have 4, 4, and 4, or 3 different options with 4 subsets off of those, which would give us 12 possibilities. And then each one of those possibilities has an option of pickles or no pickles. So if I were to count up each one of the end results here, I would say that there are 24. This is bread and cheese, and then the option of 2 for the yes or no, 1 being yes, 2 being no. Here, let's look at a different one. Let's say I'm looking at 3-digit even numbers. How many are there? Well, if it's 3-digit, the first number can't be a 0. It can't be a 1. It could be a 2. It could be a 4. Could be a 6. Could be an 8. Wait, that's silly. It can't be a 0. It can be anything. Only here do we have the contention on the even. But it can't be a 0. So 1 through 9 give us all of our possible here. This number can be 0 all the way up to 9, so including 0, that gives us 10 possibilities. Here's where we have the evens. If it's even, it needs to end in 0, 2, 4, 6, or 8, giving us 5 possible combinations for that one. When I multiply using the multiplication rule, this is just 9, and then 10 sets of 9, and then 5 sets of 90, giving us 450 possible combinations. What about an ID card? Let's say I have repeats are okay. So I could have 26 letters, and then no repeats in my 3 numbers at the end. So there's 10 possible numbers to choose from here, 0 to 9. And then once I take one of them out, there's only 9 remaining. Pull another one out, 8 remaining. So when I multiply those all together, I'm going to get a big number, which is irrelevant to working out the notes. You guys can multiply. So next thing we're going to do is we're going to go over the difference between permutations and combinations. That'll be the next video.